Welcome to your personalized deep dive.
All right.
Today, we are going to be scaling some serious heights.
Okay.
We're going to be exploring the fascinating world of mountains.
Sounds fun.
You might think it's just, rocks piled high,
Right.
but trust me,
Yeah,
it's way more complex and intriguing than that.
for sure.
You've given us some excellent source material to work with,
Right.
including a really cool
Oh, yeah.
podcast within a podcast situation
Uh-huh. Right.
that we'll get to later.
Looking forward to that.
But first, let's start with the basics.
Okay.
What exactly a mountain?
That's a great question.
Yeah,
Most people think of towering peaks when they think of mountains.
right.
But scientifically, a mountain is any landform that rises significantly above its surrounding area. So that could be a massive peak like Everest, of course.
Sure.
Or a smaller hill that stands out dramatically in a flat landscape.
I see.
It's all relative.
So it's not just about height,
Right.
but about how much it stands out from its surroundings. That's interesting.
Yeah.
And I see from your notes that there are actually 4 main types of mountains,
Yes.
each formed in different ways.
That's right. We have fold mountains, fault block mountains, volcanic mountains, and dome mountains.
Wow. But
We'll unpack each type as we go.
looking forward to that.
But first, we need to understand the driving force behind most mountain formation,
Okay.
plate tectonics.
Ah, yes, those giant moving puzzle pieces that make up the Earth's crust.
Exactly.
I've always been fascinated by how something so slow-moving can create such dramatic changes on the planet's surface.
It's pretty incredible.
Yeah,
It's like a slow motion ballet of immense forces.
I like that.
These plates are constantly shifting, colliding, sliding past, and even diving under each other.
Wow.
All this action creates incredible pressure, and that pressure is what ultimately pushes up mountains.
So it's like a geological pressure cooker with mountains as the end result.
I like that analogy.
Uh-huh.
Yeah,
That makes you think of the Himalayas.
good example.
They're the tallest mountain range in the world.
Yes. And they're still growing today, right?
That's right. The Himalayas are a prime example of mountain formation at a convergent plate boundary.
Okay.
That's where 2 continental plates are colliding.
Right.
The Indian plate is pushing into the Eurasian plate,
Uh-huh.
and that ongoing collision is what continues to uplift the Himalayas.
Wow, that's mind-boggling.
Yeah,
So convergent plate boundaries are like the ultimate mountain-making factories.
precisely. That's where the action happens. When these plates collide, the immense pressure causes the Earth's crust to buckle, fold, and even break, pushing up massive mountain ranges.
So like the Andes Mountains in South America,
Another great example.
they were formed by...
the collision of the South American and Nazca plates.
Okay, so are those the fold mountains we see in our notes?
Yes,
The ones that look like crumpled paper on a massive scale?
exactly. Fold mountains like the Himalayas and the Andes are formed when continental plates collide head-on, forcing the crust to bend and fold upward.
Okay, that makes sense. And then we have fault block mountains. Right.
Which I'm guessing have something to do with, well, faults in the Earth's crust.
You're on the right track. Think of giant blocks of Earth's crust tilting and rising along fault lines. It's like a series of steps or blocks, hence the name fault block.
I see.
The Sierra Nevada range in California and the Rift Valley Mountains in Africa are classic examples.
So those are 2 down
Wow.
fold mountains and fault block mountains.
Okay.
What about those dramatic cone-shaped peaks we often associate with mountains?
Yes.
The ones that might make you think of a volcano.
Yes. Volcanic mountains.
Right.
These are formed when molten rock or magma from deep within the earth rises to the surface and erupts.
Okay.
As the lava and ash cool and solidify, they build up over time, creating those iconic volcanic cones.
Mount Fuji in Japan
Yes.
and Mount St. Helens in the U.S.
Great examples.
Those are good examples, right?
Exactly. They're both classic examples of volcanic mountains formed through different types of eruptions.
Okay, cool.
And
All right.
speaking of eruptions, there's another process called subduction that's crucial for understanding volcanic mountain formation.
Subduction.
Yeah,
That sounds intense.
it is.
I remember it having something to do with plates moving under each other,
Right.
but I'm a little fuzzy on the details.
Basically, subduction happens when one tectonic plate slides beneath another, sinking into the Earth's mantle.
Okay.
This process generates tremendous heat and pressure, causing the descending plate to melt.
Wow.
That molten rock then rises to the surface, fueling volcanic activity and creating chains of volcanic mountains like the Cascade Range in North America, home to Mount St. Helens.
Wow. That's quite a process.
It is.
So we have colliding plates creating fold mountains?
Yes.
And subducting plates forming volcanic mountains.
Right.
What about those dome mountains mentioned in our notes?
Yes.
Those formed by volcanic activity as well?
Dome mountains are actually a bit different. They're formed when magma pushes up the Earth's crust from below but doesn't actually erupt. It's like a giant bubble of magma inflating beneath the surface, causing the overlying rock to bulge upward, creating a dome shape.
So it's like a more subtle form of mountain building.
Yeah.
Without the dramatic fireworks of a volcanic eruption.
Exactly. The Black Hills of South Dakota are a good example of dome mountains. They're not as tall or jagged as some other mountain ranges, but they have a distinct rounded shape that sets them apart.
Okay, so we've got our 4 main types of mountains.
Right.
Fault block, volcanic, and dome. Each formed by different tectonic processes.
That's right.
But mountains aren't just static structures, are they?
That's a great point.
I mean, they're constantly being shaped by other forces too, right?
You're absolutely right. We've talked about the powerful forces that create mountains,
Right.
but there are other forces at work that constantly shape and reshape them over time.
Interesting.
These forces are erosion and weathering.
Erosion and weathering. I remember learning about those in school.
Of course.
Could you remind us what they are and how they affect mountains?
Sure. Weathering is the process of rocks breaking down into smaller pieces due to exposure to elements like wind, rain, ice, and even plant roots.
Right.
Erosion, on the other hand, is the transportation of those weathered rock fragments by wind, water, or ice.
Okay.
Together, these processes wear down mountains, carving out valleys, smoothing out peaks, and transporting sediment that ultimately creates new landforms elsewhere.
That's fascinating.
It's like a constant dance between creation and destruction, with tectonic forces building up mountains and erosion and weathering working to wear them down. And this dance plays out over vast stretches of time.
Right.
What do geologists call deep time.
Deep time, that always makes my head spin a little.
Yeah.
I mean, we're talking about processes that take millions, even billions of years, right?
Exactly. It's hard to grasp the sheer scale of time involved in mountain formation and the constant changes that shape the Earth's surface, but that's what makes it so fascinating.
Yeah, for sure.
And speaking of fascinating, remember that podcast within a podcast we mentioned earlier? It turns out they did a whole episode on mountain formation too, and they had some really interesting points that tie in perfectly with our discussion.
Oh, yeah. I remember you saying they covered the difference between mountains and hills.
Yes.
Which I've always been a bit fuzzy on. Is it just about height?
That's a common misconception. While height is a factor, with mountains generally exceeding 600 meters.
Okay.
It's not the only thing that distinguishes a mountain from a hill's steepness, also plays a role.
Okay.
Mountains tend to have much steeper slopes than hills,
Right.
which contributes to their dramatic, imposing appearance.
That makes sense. A gentle rolling hill just doesn't have the same wow factor as a towering, jagged peak. And speaking of wow factors, I'm curious about the speed of plate movement. Does that affect how mountains are formed?
Absolutely. The faster the plates move, the more dramatic the uplift and the quicker the mountains rise. But keep in mind that we're still talking about geological timescales here.
Right.
Most plates only move a few centimeters per year. So even fast movement is incredibly slow by human standards.
That's wild. It's amazing to think of these massive plates creeping along inch by inch over millions of years.
I know.
Eventually creating these colossal features we call mountains. And they highlighted something I found really interesting.
Oh, yeah.
The idea that the Earth's crust is constantly adjusting to maintain a balance.
Ah, yes. You're referring to the concept of isostasy.
Isostasy.
It's a bit like a seesaw, but instead of kids, we're talking about massive chunks of the Earth's crust.
Okay.
As mountains are eroded, the weight on that section of crust decreases, and it slowly rebounds upward to maintain equilibrium.
So it's like a dynamic process that plays out over very long time scales.
Yes.
So even as erosion wears mountains down, isostasy can keep them elevated.
Right.
That's pretty cool. And they also mentioned orogeny.
Orogeny.
Which sounds like something out of a Greek myth.
It does have Greek roots, but it's simply the term for the process of mountain building. So each mountain range has its own orogenic story to tell a record of the tectonic forces that shaped it over millions of years. For example, the alpine orogeny is what created the Alps we know today.
So mountains are like time capsules preserving the history of the Earth's movements.
In a way, yes.
That's fascinating. And speaking of fascinating, the podcast host Mike and Sarah did a great job of explaining how technology has revolutionized our understanding of mountain formation.
They did a good job. They highlighted the role of satellite imagery and remote sensing, which allows scientists to map tectonic activity and monitor changes in real time.
So it's like
Yeah.
having eyes in the sky, watching the Earth's crust move and mountains rise.
Exactly.
That's incredible. We can actually see those processes happening, even though they're so slow.
That's right. And that data is crucial for understanding not just the how of mountain formation, but also the why. Why do mountains form where they do? Why are some taller than others? And what are the implications for the planet as a whole?
Because, as we've already touched upon, mountains are more than just geological wonders.
Right.
They have a profound impact on the environment and on life itself.
And Mike and Sarah wrapped up their discussion by focusing on this environmental impact. They talked about how mountains influence climate, particularly by creating rain shadows.
We've already mentioned how the Rockies block moisture, creating deserts on the other side. It's a dramatic illustration of how mountains can shape regional weather patterns.
Exactly. And they also discussed the role of glaciers in carving out those iconic U-shaped valleys and cirques we see in mountain ranges.
Glaciers are like nature's bulldozers, reshaping the landscape as they slowly flow down mountain slopes. It's amazing how powerful something as seemingly still as a glacier can be.
It really is. And let's not forget the incredible biodiversity found in mountain ecosystems.
All right.
Mountains are home to a vast array of plant and animal life, many of which are uniquely adapted to the harsh conditions found at high altitudes.
So mountains are like islands of biodiversity,
Yeah.
each with its own unique set of species and ecosystems.
Exactly. And they act as important corridors for species migration and gene flow, connecting different habitats and allowing species to move and adapt to changing conditions. So mountains are not just static structures, they're dynamic ecosystems that play a vital role in the web of life on Earth.
Wow, I'm really starting to see mountains in a whole new light. There's so much more than just rocks piled high. They're climate regulators, biodiversity hotspots, and indicators of the Earth's deep history.
That's a great way to put it, and that's just the tip of the iceberg. There's so much more to explore and understand about these incredible landscapes.
For sure.
And Mike and Sarah ended their podcast with a thought-provoking question. How has mountain formation evolved over time?
That's a great question.
Yeah.
It makes you realize that the Earth is constantly changing, and the mountains we see today are just snapshots in a long and complex geological history.
Right.
They're still evolving, still being shaped by the forces we've been discussing.
They emphasize that the locations and shapes of mountains reflect millions of years of tectonic activity, offering clues to the Earth's dynamic past.
It's like reading the story of our planet, etched into the very rocks that make up these majestic peaks.
I like that.
And that story is still being written today, as tectonic plates continue to move, collide, and reshape the Earth's surface.
And just as mountain climbers face challenges and triumphs on their journey to the summit, so too does the Earth face its own challenges as it continues to evolve and change.
It feels like we've climbed to a new understanding of mountains today.
Yeah.
But as you said, the journey doesn't end there.
Right.
Especially when we consider the challenges mountains are facing in a rapidly changing world.
Exactly. We can't talk about mountain formation without considering how these landscapes are being impacted by climate change.
Glaciers are melting at an alarming rate, which affects water resources for millions of people. And those delicate, high-altitude ecosystems. They're facing unprecedented challenges as temperatures rise and weather patterns shift.
It really highlights how interconnected everything is, what happens in one part of the world.
Right.
Even seemingly far away can have ripple effects on mountain environments thousands of miles away.
It makes you realize that mountains aren't just these static backdrops.
Yeah.
They're dynamic living systems that are constantly evolving, and we have a responsibility to understand and protect them.
Absolutely. And that understanding starts with curiosity, with asking questions and seeking answers, just like you've done today by taking this deep dive into mountain formation.
I have to say I'm feeling pretty inspired right now.
Good.
It's amazing how much we've learned just by exploring these different sources, from scientific definitions to those real-world examples Mike and Sarah shared in their podcast.
It is really cool to see how all of those pieces fit together.
Yeah.
That's what makes this so rewarding. It's about connecting the dots, weaving together different perspectives to create a richer understanding of the world around us.
And just like a mountain climber who reaches the summit, we've gained a new perspective, a broader view of the landscape.
But the journey doesn't end there.
Right.
There are always new peaks to climb, new insights to uncover.
So where does this leave us? I think we've laid a solid foundation for understanding how mountains are formed, the forces that shape them, and their significance for the planet.
Yeah, I think so too.
But there's always more to explore.
Exactly. And I think a great place to start is by considering how climate change will continue to shape the mountains we know and love.
Right.
What changes are we already seeing, and what can we do to protect these majestic landscapes for future generations?
Those are definitely questions worth pondering.
For sure.
And on that note, we'll wrap up this deep dive.
Okay.
But we encourage you to keep asking questions, keep exploring, and keep that spirit of curiosity alive.
Because just like the mountains themselves, our understanding of the world is always evolving, always growing.